screw-stop tab located on the opposite end of the inner shaft. In this example, we will reinstall the lever to establish an angle of between 63 and 73 degrees, measured between the center line of the inner shaft lever and the screw-stop tab. With the arm positioned at the correct angle, now install the washer and screw and torque to the correct value. Recheck the clearance before starting the next step. Incidentally, maintenance manual procedures instruct you to apply slippage marks on each item of retaining hardware. This is good practice because these slippage marks will warn you if an adjustment has changed since completing the rigging procedure. The final step in the concentric shaft assembly is to install the 3 adjusting screws. Screws V and X are installed into the outer shaft arm, and screw W is installed into the inner shaft lever. Since these screws are adjusted during the final steps of the rigging procedure, temporarily position each adjusting screw so that approximately 5 threads remain. It's important to remember that the concentric shaft can be easily assembled if you follow the step-by-step procedures outlined in the maintenance manual. Before we conclude part 1 of this 3-part video program, let's take a few moments to review the function of the concentric shaft. As a component of the engine control system linkage, the concentric shaft assembly interconnects and coordinates motions between the various control system functions. It's helpful to remember when troubleshooting a control system problem that incorrect assembly, interference, or binding within the concentric shaft assembly can cause you problems when rigging the control arms, rods, and levers that connect fuel and propeller system components. Needless to say, it can also produce abnormal control function responses during engine operation. During part 2 of this program, we will continue with the installation of the engine control linkages. We'll install and rig the control rods, arms, and levers that interconnect the propeller pitch control to the manual fuel valve and the underspeed governor to the propeller governor.
Built up. What I'll go ahead and do is I'll put in the quadrant plate and the rigging plate, and then I'll take the measurement from the bracket to the center of the control shaft.
You are going to take it from here to here?
Yes.
Okay. That'll be fine. Thanks. In part 1 of this 3-part program on TPE331 engine rigging, we reviewed control system operation and covered the procedures to assemble and install the concentric shaft assembly. During this part of the program, we'll cover the installation and rigging procedures for the control rods, arms, and levers which interconnect the engine control system components. The procedures we'll discuss parallel the specific instructions as found in Chapter and Section 7610.01 of the Maintenance Manual. Part 3 will follow, discussing the rigging procedure verification process, and will also describe the techniques used to make the final adjustments that ensure control functions are precisely matched for both engines. After viewing this 3-part series and by applying the most recent maintenance manual procedures, you should be able to install, rig, evaluate, and correct control system rigging problems. It's a standard practice when a maintenance action requires the removal of a control system component or components to disassemble the control linkage only to the extent necessary. However, for training purposes, we'll describe in detail the complete installation procedures for the control system linkages. To facilitate the taping of this program, the engine is removed from the aircraft and will be rigged in a lab setting. Although the basic installation procedures for the various linkage assemblies will apply in general to all engine models, the measurements and angles that we'll use here are for illustrative purposes only and may not apply to your specific engine installation. Remember, though, in all cases, the maintenance manual supported by the illustrated parts catalog for your engine model application will supersede this training program. Let's begin now by installing the linkage which interconnects the propeller pitch control shaft to the manual fuel valve shaft. On the fuel control unit, the manual fuel valve shaft is identified as a power shaft. Next, we'll install the linkage between the propeller governor shaft and the underspeed fuel governor shaft. Again, on the fuel control unit, the underspeed fuel governor shaft is identified as the speed setting shaft. To simplify the installation procedure, let's first identify each part of the control linkage system which connects the propeller pitch control to the manual fuel valve.
These items include the rigging pin plate, the quadrant protractor plate, the spacer sleeve, a spacer washer when required, the serrated lever assembly, the propeller pitch control rod assembly, the manual fuel valve rod assembly, and the adjustable arm assembly for the manual fuel valve shaft. Additional items include the special spacer washers and retaining hardware. It's helpful to remember, when reinstalling a repaired pitch control or when replacing a pitch control with a new unit, that these parts are more easily installed prior to installing the pitch control on the engine. The first step in the rigging procedure is to install the rigging pin plate, the quadrant protractor plate, and the spacer sleeve onto the pitch control shaft. Visually check that the spacer sleeve properly fits into the rigging pin plate, and then install the retaining screws and washers. Do not tighten the screws, since the protractor and rigging pin plate must be aligned to the pitch control shaft. Incidentally, if the effectivity code for your engine model application requires a special spacer washer on the pitch control shaft between the spacer sleeve and the serrated lever, install it at this time. Next, rotate the pitch control shaft fully clockwise to the full reverse position. While holding this shaft position, align the lever pointer as close as possible to 0 on the protractor plate, and slide the serrated lever onto the splined shaft. In order to achieve the best possible alignment, don't hesitate to remove and then re-index the lever onto the splined shaft if needed. Now, torque the lever retaining screw to the specified value as found in your maintenance manual. Although torquing the screw isn't really necessary at this time, it may prevent an alignment change after adjusting the protractor during the next step. Install a 1/8 inch diameter rig pin through the pitch control lever into the reverse slot of the rig pin plate. While maintaining the pitch control lever and rigging pin plate at full reverse, adjust the protractor position so that 0 aligns with the lever pointer, and 40 on the protractor is centered on the 40-degree rig pin slot. Now, without moving the protractor, carefully tighten the retaining screws. Torque the screws to the specified value as found in your maintenance manual. Remove the rigging pin and make sure the pitch control lever and shaft rotate freely. Also verify that the lever moves from 0 to 100 plus or minus 3 degrees.
If full travel for the lever is not indicated on the protractor, repeat the process. First, making sure that the rigging pin and the pitch control shaft are in full reverse.
After verifying that full pointer travel is indicated on the protractor, position the lever at the 40-degree marking and again install the rigging pin. Verify that the lever pointer aligns with 40 degrees on the protractor within plus or minus 1/4 degree. Remove the rigging pin and rotate the lever fully clockwise to the reverse position. Now verify that 0 degrees on the protractor aligns with the pointer and that this alignment is maintained with the rigging pin installed. If you didn't tighten the screw that secures the serrated lever to the pitch control shaft before, do so at this time. After tightening the screw, recheck alignment at 100 degrees, 40 degrees, and at 0. If the alignment at any one of these 3 positions is not within maintenance manual limits, realign the quadrant protractor plate using the procedures we've just described. When the pitch control setup is complete, apply slippage marks on the retaining hardware. If the rigging process is being performed on the bench, then install the pitch control according to maintenance manual instructions as contained in Chapter and Section 7210. Next, we'll install and adjust the rod assembly connecting the pitch control lever to the concentric shaft. To determine the required length for the rod assembly, measure the distance between the center line of the pitch control shaft and the 1-inch diameter machined surface on the concentric shaft bracket. Record this measurement as dimension A. Add 1/2 inch to dimension A to obtain the distance between the center line of the pitch control shaft and the center line of the concentric shaft. Now, adjust the length of the rod assembly to this dimension. Measuring from center line to center line of the rod end bearing bolt holes. With the rod length adjusted and the lock nuts tightened, measure the exposed threads on the stud and compare this measurement to the minimum and maximum dimensions shown in the maintenance manual. If these dimensions are not within the specified range, then add or remove washers between the lock nut and the rod end as required. With the rod adjusted to the required length, tighten the lock nuts to the specified torque value. Make sure the rod ends are aligned with each other so that binding in the control linkage doesn't occur. Now, recheck the rod lengths. It should be within plus or minus 2/100ths of an inch of the required dimension.
Before we install the pitch control rod assembly, let's discuss the hardware required for the control linkage rod ends. Using the pitch control rod as an example, the illustrated parts catalog provides a breakdown of the bolts, nuts, and special washers required for installation. The IPC breakdown identifies the required number and location of special spacer washers according to their relative thickness. If these special washers are not installed at their proper location, control linkage binding can occur.
Select the correct hardware and install the bolt into the pitch control lever. Normally adequate clearance to install the bolt is obtained by rotating the lever counterclockwise to 100 degrees. Next, install a 50,000th spacer washer. the rod end bearing, a 20,000th spacer washer, a 20,000th large diameter special washer, and a nut. The nut should be tightened to the specified torque value. If required, additional large diameter washers can be used to obtain the best nut position for later cotter key installation. Now, with the opposite end of the pitch control rod connected to the outer shaft lever on the concentric shaft assembly, rotate the pitch control lever to check for freedom of rotation and full travel. In the next steps, we'll install the control rod and manual fuel valve adjustable arm assemblies. First, let's obtain the correct control rod length by measuring the distance between the center line of the manual fuel valve shaft and the center line of the concentric shaft. This measurement should be recorded as dimension B. Now, adjust the control rod assembly to this measured B dimension. Again, the control rod is measured from center line to center line of the bolt holes in the rod end bearings. As before, observe and adhere to the minimum and maximum exposed thread dimensions on the stud. After tightening the lock nuts to the specified torque value, check that the rod ends remain aligned. Before installing the rod, recheck its length. It should be within plus or minus 2/100ths of an inch of dimension B. Install one end of the control rod to the concentric shaft outer lever, making sure the special washers are correctly placed on each side of the rod end. Tighten the nut to the specified torque value. After this is completed, rotate the pitch control to the 0-degree position and install a rigging pin to maintain this alignment. If the manual fuel valve adjustable arm has been disassembled, it should now be reassembled. With the lock nut loose, center the serrated arm by rotating the adjusting screw. Do not tighten the lock nut at this time. Next, connect the rod assembly to the adjustable arm by using the required special washers and nut. And tighten the nut to the specified torque value. Rotate the manual fuel valve to the 0-degree position to match the position of the propeller pitch control. The next step is installing the adjustable arm onto the manual fuel valve splined shaft. For installation ease, and to maintain the manual fuel valve pointer alignment at 0 degrees on the protractor, it may be necessary to rotate the adjusting screw slightly. Here's another helpful suggestion. If the adjustable arm can't be raised high enough to engage the manual fuel valve shaft due to control rod interference, then loosen the nut and bolt attaching the rod to the concentric shaft and retorque after the adjustable arm is installed. Now, with the adjustable arm installed and the manual fuel valve pointer aligned at 0 degrees, the rigging pin should be removed from the pitch control. The removal of this pin prevents possible control linkage binding while tightening the adjustable arm lock nut. Now hold the adjusting screw and tighten the lock nut to the specified torque value. Next, rotate the pitch control fully clockwise. If the adjustable arm has been correctly installed onto the manual fuel valve shaft, a rigging pin should fit freely into the pitch control reverse slot, and 0 degrees should be indicated on the pitch control and manual fuel valve protractors. With the pitch control shaft rotated fully clockwise, and if an error of approximately 10 degrees is noted on either protractor, then the adjustable arm on the manual fuel valve splined shaft will probably require re-indexing.
These splines provide a coarse adjustment, while the adjusting screw serves as a fine adjustment. Do not attempt to correct a large positioning error by turning the adjusting screw in the manual fuel valve arm assembly. Instead, re-index the manual fuel valve arm on the splined shaft.
Now, with the pitch control and manual fuel valve protractors aligned at full reverse, remove the rigging pin. Rotate the controls to the 40-degree position and install the rigging pin into the flight idle slot. Next, make sure that the manual fuel valve pointer aligns with 40 degrees on the quadrant protractor. If necessary, you may have to loosen the lock nut and rotate the adjusting screw to align the pointer to 40 degrees plus or minus 1/4 of a degree, and then retighten the lock nut to the correct torque value. Remove the rigging pin and operate the control linkage between full reverse and maximum, checking for freedom of rotation and full travel. If binding or interference occurs in the control linkage system, you'll have to recheck each of the installation and adjustment procedures. Also, verify the correct angular relationship between the outer shaft lever and the concentric shaft assembly outer shaft serrated lever.
Before continuing, let's take a few moments to explain a useful procedure when checking the propeller pitch control and manual fuel valve rigging. To accurately check and verify control system rigging, engine linkage should be operated through its full range of travel from the same point where the power lever input rod connects to the system. Depending upon the installation, the power lever input rod will either connect to the pitch control shaft or to the manual fuel valve shaft.
To verify flight idle rigging, set the control linkage at maximum and rotate the linkage to the 40-degree position. It's important to remember during engine operation, when power levers are pulled back to the flight idle gate, the adjustments for flight idle fuel flow and flight idle blade angle must be both predictable and repeatable. Now, let's make sure that this engine rigging procedure has been successfully completed. First, rotate the controls to maximum and verify that the pitch control and manual fuel valve protractors align at 100 degrees and are within maintenance manual limits. Next, rotate the linkage back to the flight idle position. Verify that the rigging pin fits freely and that both protractors are aligned at 40 degrees plus or minus 1/4 of a degree. With the rigging pin removed, rotate the linkage to full reverse and reconfirm rigging pin installation and that both protractors are aligned at the 0-degree position within maintenance manual limits.
If incorrect alignment is indicated on either the pitch control protractor or manual fuel valve protractor at even one of these three positions, then each step of the installation procedure should be rechecked.
This recheck includes the pitch control setup, control rod lengths, and the manual fuel valve adjustable arm installation. After verifying that the pitch control and manual fuel valve rigging is correct, the next step is to install the spacer, washer, and screw onto the power lever shaft. Then tighten the screw to the correct torque value. However, these items would not be required if the power lever input rod connects to the manual fuel valve splined shaft. Check the torque values on each item of the retaining hardware, then install the cotter pins and apply slippage marks according to the maintenance manual procedures. Moving now to the propeller governor and underspeed fuel governor, let's identify each control linkage component. First, we see the adjustable screw and locking nut for the propeller governor arm. Next, the propeller governor rod assembly and the underspeed fuel governor rod assembly. The underspeed fuel governor speed setting lever and its matching serrated plate. Finally, the serrated arm and the underspeed fuel governor input lever. Additional items include the special spacers, spacer washers, and retaining hardware. Now, the first step is to install the threaded adjusting screw into the propeller governor arm. If you encounter interference with the engine or adjacent components while installing this screw, adequate clearance can be provided by rotating the propeller governor arm to its high stop. With the adjusting screw installed, position the screw to the center of its adjustment range. This adjusting screw establishes the correct separation between the propeller governor and the underspeed fuel governor when the propeller governor is at a minimum cruise RPM setting of 96%.
Even though the separation check and adjustment will be performed during Part 3 of this rigging procedure series, here's a helpful hint for establishing the initial position for the adjusting screw.
Temporarily install the propeller governor control rod, making sure the special spacers are correctly placed on each side of the rod end bearing. Now, position the adjusting screw to obtain a 1-inch to 1 1/8 inch measurement between the propeller governor shaft center line and the center of the rod end bearing. With the adjusting screw held in this position,